Yeah, so this talk's entitled Exploration in the Ravenswood Goldfield. I'd sort of like to give a bit of a summary, really, on the general geology of the Ravenswood batholith and the sort of... Oh, sorry. A bit taller. Or it's a bit floppy. Yeah, I put myself off now. And just summarise some of the deposits that the area is well known for, and give some examples of Sunshine Gold's exploration activities to look for these deposits. And really, it's I think the Ravenswood area is fairly exciting for us as a junior explorer. We don't have any resources at Ravenswood as of yet. But we certainly think it's got great potential to be a game changer for us. Just as a quick summary of the Ravenswood batholith in general, it's located in the Charters Towers province. That's just west of Townsville in North Queensland. To the north is the Broken River province. To the south is the Drummond and Bowen basins. And for someone like myself who's sort of fairly new to the Ravenswood area, it's really exciting just to get working in there and just see how underexplored and undercooked this area is. Even though it's an area that's produced over 20 million ounces of gold, even more so silver. And it's also prospective for copper, moly, lead, zinc, and some new economy metals as well. Some of the most well-known deposits in the area, they're Ravenswood, Charters Towers, Mount Lation, Mount Wright. They're all gold deposits, and you get some VHMS deposits as well, like Thalanga. Oh, my formatting's a bit funny there, but the regional geology. So generally in the batholith area, the basement rocks tend to outcrop in the south. They're Cambrian to early Ordovician in age. They're metasediments and metavolcanics of the a large group of them belonging to the 70-mile range group. The first sort of phase of intrusive activity was in the early Ordovician, and these are predominantly granites, and they outcrop predominantly in the north. And some of these are often a bit strained and recrystallised owing to deformational events which occurred shortly after they were emplaced. The second stage, and quite significantly in the history, is Silurian magmatism into early Devonian. These are predominantly granodiorites and tonalites. And these tend to account for about 60% of the exposed batholith area, so really quite a significant package. And together with that, they're very significant in the sense that they're temporally and spatially associated with gold mineralisation in some areas, most notably at Charters Towers. And finally, the last intrusive event, I suppose, is in the late Carboniferous to early Permian. These are plutonic to volcanic rocks, and they account for just about 6% of the exposure. However, they're quite significant again because they're also associated with gold mineralisation at Ravenswood, for example, and at Mount Wright as well. Notably, two of the larger intrusive areas here are in the Sunshine Gold tenure, which is the Tucker Range Igneous Complex and the Bouri Igneous Complex. There are a lot of sediments out to the west, and even in the batholith itself, there tends to be a light, thin covering of tertiary and quaternary sediments. Structurally, it tends to be there's a number of shortening events that's occurred during the batholith's history. The first of which gave rise to some myelinitic shear zones. predominantly in the north and east-west striking, such as the Mosgadi shear zone. More brittle structures sort of came in later deformational events and mafic intrusives as well. And some of these brittle structures were reactivated during the mineralizing events later. In terms of mineralization ages, we sort of touched on it as well previously. For gold in particular, there tends to be two sort of main age groups. Charters Towers and Hadley Castle around the 410 mark at Silurian age, and Ravenswood and Mount Wright, for example, around the 305 age. In terms of where we're located, in the Batholith, we mainly located there on the western side, around Ravenswood and Mount Wright itself, with a small package of tenure just north of Hadley Castle. And yeah, it's prospective for all the elements that we mentioned earlier, and I'll try and go through a few deposit types. Firstly, when we picked up the tenure, it was really great to see that there was a really good open file database for geophysics, geochem, and geology over the area. This map is just a quickie, I suppose, that I did up based purely on the magnetics of the area. This is reprocessed magnetics. This has all been open file. And it's a composite image of a number of surveys, but SGC did a great job of reprocessing all that for us, and the amount of value that we've had out of that has just been a godsend, really. So it's allowed us to subdivide a number of intrusions. You get to see all the structural relationships. And look for new areas of interest which are away from the main prospect areas as well. And so I think this has really just highlighted the importance of and value of open file data sets for us, as a junior company. Furthermore, there's a good geochem database open file as well, which we've been using quite heavily. Obviously with any geochem database, it's important to validate that as much as you can. There's different sample methodologies, analysis methodologies, and lots of ppm versus ppb discrepancies that you need to sort out. But you get through it, and it's really an invaluable tool. And the next image is the open file drilling data, and so you can see it's quite striking how scarce the drilling is in there, and that really to me says two things. One is that there's genuinely obviously drill holes missing from the open file database. You can't have everything. That would be nice, but old holes on dodgy local grids or on mining leases, they just don't make it in there, and that's when you've got to try your best to go through the old historical reports and see what you can do. But even factoring that in, there's a significant lack of drilling within the Ravenswood area, at least within the areas that I've been looking at, despite there being such a good geophysical data set, well-known deposits in the area, geochem data, which is producing quite a lot of anomalies. So it's very under-drilled, particularly at depths over 100 metres. So in terms of types of deposits in the area that we're exploring for, this is a very simplified slide, obviously. All deposits have their own unique characteristics. But the most productive deposits in the area have been the mesothermal gold, so Charters Towers and Ravenswood in particular, and they're hosted within those granitoids of Silurian age predominantly. And in terms of the mineralization, they tend to be in shallowly dipping quartz vein structures. essentially within fractures within the granites, pretty much. Where they have an interplay with some of the subvertical faults, it tends to be an important localizing factor. Essentially what you'd be exploring for these type of deposits is where you get a good density of these veins. They have quite distinct sort of sericitic halos, gradient outwards to chlorite in more distal areas. And one of the areas that we've been looking at that sort of lends itself to this style of target is at Dreghorn. That's probably about 20 kilometres south of Ravenswood, and it just straddles the Burdekin River there. And the main thing, it's located in one of these Silurian granites called the Karsagari granite, and it was immediately of interest to us because it was a 9 kilometre long gold in soil anomaly, often exceeding well over 100 ppb. That had very few drill holes into it. Review of that mag data that we have as well shows an area of fairly structural complexity. You tend to have these regional sort of northeast trending structures parallel to the soil anomaly, and also some northwest structures. And these are both later cross-cut by east-west structures. And that's all picked up from that open file data. So we did a few more soils, extended the grid, a bit of check mapping as well, and we did some reconnaissance drilling to check a few anomalies and to check a few of the structural orientations. We intercepted some narrow high-grade, high-ish grade intervals, around the 1 gram at 8, 1 gram at 6, those sort of things. We really need to take a bit more stock of this one and put our thinking hats on, do a bit of mapping if we can. There is a lot of cover, but we'll do what we can, and perhaps do some more detailed ground magnetics over areas of interesting geochem as well, to see if we can get an area where these veins coalesce. The intrusion-related gold story is one that's quite important to us, and it's certainly important to the region as well. And those are your Mount Wright style deposits. These are hosted within the causative intrusion, the permocarb rhyolite intrusives, and Mount Wright was certainly of interest because it was essentially a blind gold deposit. There was an outcropping area called the Mother Lode, just up here, that was hosted and certainly associated with the main lode, but it was actually hosted within a granitic breccia. The main mineralization at Mount Wright didn't kick in until about 150 metres below surface. And another interesting thing with Mount Wright as well is that you've got a zonation of metals. So you've got lead, zinc, and other base metals elevated towards surface. That actually gives you a decent soil anomaly on surface as well. But the economic grade, gold only kicks in with pyrite from about 150 metres depth, pyrite markazite. And eventually that drops out even deeper down, about 800 metres depth, where it just goes to a pyrite assemblage, pyrrhotite assemblage. In terms of exploration for us and what we're looking at, Wilbur's Hill is an example of one of these targets. It's located on the periphery of the Buri igneous complex. That's this area here, and these permocarb intrusions are quite distinct in magnetics due to magnetic reversal. So it's located in the right time of intrusive. It's in the right rocks. There's rhyolites, there's flow-banded rhyolites and brecciated rhyolites. And we see some white micro-alteration on surface. And on top of that, it's got quite a distinct coincident geochem signature. It's coincident geochem for gold, zinc, lead, bismuth, tellurium, copper, silver, and arsenic as well. So it's certainly of an interest to us, and we were fortunate enough to get a GSQ grant to do a IPMT survey over the area called Titan. And previous works at Mount Wright suggested that a coincident low resistivity and chargeability anomaly should produce a good result. So we're hopeful for that, and we'll kick that off in the next few weeks. We've got some porphyry sort of related copper and moly stories as well. Notably, there's never been any mined porphyries to any extent within the Ravenswood Batholith. However, I personally think it's a bit undercooked. They were really last looked at, by all accounts, in any detail in the 1960s. So it's been a long time. Things have changed a little bit since then. And there's a number of these porphyry targets within our leases, starting up in the north in an area called Titov, and going south to an area called Gagarin. These are quite topical names. And Bankbrecher there at the bottom is on the other end of the 15-kilometre trend. So we actually drilled Titov in late 2021, and that was the first drilling done there since 1969. We were sort of validating some historical broad copper moly intercepts, but also tests for a full suite of elements. There was never any analysis for silver or gold through here. And while we found a little bit of silver through there, the gold was a little bit sporadic. I think in the first few drill holes we had a maximum of I think it was 1 meter at 0.2 or something. But the gold does seem to be increasing towards the eastern side, where there's actually a coincident geochem anomaly for gold as well. So we'll follow up on that. But we intercepted broad copper and moly mineralization, predominantly within red rock altered granodiorite, and with a sort of a high grade hanging wall footwall. And there's a sort of a core of a quartz vein array with strong sericite alteration that sort of locally upgrades the molybdenite and chalcopyrite as well. So we did a little bit of an IP survey, mainly to see if we can chase sort of the gold out to the east as well. And we found that the main area that we drilled, which is here, has a strong chargeability anomaly associated with it. So that's a good sign. There's also significant chargeability to the south, and I'm sure part of this is an edge effect as well. But we are going to have a little look in this area, considering as we did get some small but higher grade intervals through there as well. And really we need to understand this a lot better. At the moment we've put 8 drill holes into it. We haven't looked into any great detail in the geochem just yet about which parts of potentially of the system that we could be in. So it's very early stage, but we'll get there. Finally, the other style in the area is one that we haven't touched on as an exploration company as of yet, but still significant. That's the VMS deposits. They're fairly modest in the area, but they can be high grade at times as well. So it is quite interesting, and they're predominantly hosted within those 70-mile range group basement rocks. In the south, this is sort of to the south of that Dreghorn area. This is an area called Bowerbird, and this is a 50 ppm lead anomaly, which is quite evidently strata-bound. And it's just to the west of a known VHMS deposit called Magpie, which is, again, very small, but it's got a bit of grade to it as well. And Bowerbird has never really been tested, and it's an interesting target and one I think is worthwhile having a look at, and we'll get to there when we get there. But as you can appreciate, there is a lot of area to look at here. And this is a little sort of cheeky one on the end, I suppose. The Elphinstone Creek is an area that we looked at primarily because there was gold in stream sediment samples up to 6 grams per tonne, and that's still the main focus for us. But also what was notable about that as well was there was a significant amount of rare earths. So it was up to over 2% total rare earth oxides within the stream seds. This geophysical image here is a radiometrics potassium, and this is a very distinct intrusive in the area called the Barabbas adamelite. And we're actually undertaking a soil sampling survey in the north where there's a fault structure, and we brought it down to start having a look at this stuff through here. Sort of that contact really lights up with the rare earth elements through there. So those are, anything not blue is total rare earth oxides over 400 ppm. So it's quite interesting. It's sort of a bit of a gold and a rare earth thing. I assume the gold is going to be similar to a Ravenswood style thing if it's there. And the rare earths is a very new thing for us. We also got a grant to complete that soil survey as well. So we'll get that done, and then we'll take stock of what we got there, but it's really exciting. Finally, so exploration in Ravenswood. So yeah, we've been very active and looking at all sorts of different deposits since we took up the ground about a year ago. I personally think it's quite underexplored, but it's very well endowed, and we should be looking at it, we should be drilling some holes out there. The open file stuff has been really, really good for us, and we'll. Thanks for any previous operators that have added to that. It's been great, and it's a very model-driven area. There's been a lot of academia through there, which is great, and we can certainly build on that. I hope as well. But it's good to think outside the box sometimes as well, and drill a few holes where maybe other people haven't as well. So it's and also assess for these new economy minerals as well. I think it'd be worthwhile, particularly in these old terrains where they often assayed for only 2 or 3 elements. And that's about it. Thank you very much.